Hello smart people. So this is our 15th lecture on tensors. तो अगर आपको पता होगा in our previous lecture we have discussed it. तो हमने वहाँ पे discuss किया था if we talk about the tensors, if you take the derivative of a tensor, right? So if you take the derivative of a tensor and so the resultant that tensor should be of same rank. So we can get some new tensor but of same rank. Suppose I already give you some example when we do the coordinate transformation, but what we observe when we take the derivative of these tensors, so we are finding some kind of this equation. तो आपको पता होगा. So we are basically getting this kind of equation by making the variation of that coordinate displacement, right? So by taking the variation of this coordinate displacement, so we get basically this kind of equation. So that means, so this one corresponds to our velocity component because you can write this as that dx prime mu upon d tau. So that's equal to delta prime mu nu lambda mu dx mu upon d tau. Right? So we have discussed these things. तो यहाँ पे मेरा कहने का मतलब है, अगर हम देखेंगे for example this when you put that this nu equal to mu prime, you are basically getting first a velocity component and you are getting the same this you are getting the tensor of same rank because it has some rank nu prime, so you will get the same rank here also, right? But in addition to that, we have this kind of this term. So that means we have this second order this derivative of this coordinate transformation, this x mu, right? So that second order derivative basically poses a big problem for we people because what we are saying that every physical quantity it should remain invariant if you go from some one frame to another frame, right? So that means if you go for coordinate transformation, तो यहाँ पे हम basically क्या देख रहे हैं कि when we do the coordinate transformation, like if you are going from this x prime mu to some new coordinates, right? So the real rank of the tensor should remain same, but there is a different story. So you can see here this term basically corresponds to the variation of the old coordinates with respect to the new coordinates, right? Because our old coordinate that's nu prime and these are some new coordinates, so this indicates the variation of that variation of this old coordinate with respect to the new coordinates. And this term basically if you interpret it, तो मैंने आपको बताया था अगर if you talk about this in this Galilean transformation or if you talk about the Lorentz transformations and these this equation holds there, so this term will be non-zero there. तो ये term हमारी zero बनती है वहाँ पे, right? But if you talk about this this if we have something on sphere, like or if you talk about, so we have some motion kind of a motion that is this is basically the trajectory of the particle, right? And the velocity component is tangent to this, right? So but ये कहाँ पे है? So that means this is applicable if you talk about this on this Euclidean spaces, right? Okay, now if you go in some curved spaces, so this RT and VT are not in the same plane, but in the this Euclidean spaces they are in the same plane, right? So what basically that indicates, so as I already told you, I am revising some of the things. So this term comes out to be the curvature of space time, right? तो मैंने आपको दिखाया था अगर हमारे पास एक sphere होगा, right? If we suppose we have some sphere and अगर मैं if I consider some small patch on this, तो एक small patch में यहाँ पे लूँगा. तो if I'm seeing outside, तो outside से मुझे क्या दिखेगा? मुझे एक curved patch दिखेगा, right? So मेरे लिए ये curved है, but अगर if there is some person which is lying on a sphere, अगर कोई person इस sphere पे होगा, तो उसके लिए क्या होगा? It will be simply plain sheet, right? So that means for the person who is on this sphere, तो उसके लिए there is one dimension is hidden there, right? So one dimension hidden for him. Okay. So but for me, so because I am living in some this three-dimensional space, right? So I'm basically observing that it is the curved that the two-dimensional shape, right? So for this person, one dimension hidden. So that means this is when I talk about this Euclidean plane. So I am in the three-dimensional curved space time, right? So this is what we have discussed, is that the second order derivative comes due to the curvature of this space time, curvature of space, I mean to say, right? Now, now there is another topic that is about, as I already told you, I can give you one powerful example related to this curvature of this space. So that's basically called affine connection, right? So affine connection basically connects the two coordinates, right? So this is related to somewhat of this second this derivative, this second order, right? So that topic is basically that's called affine connection. So before starting this lecture, so I will give you some example of some free fall. So अगर आपने if you are a physics student or mathematics student, maybe you might have come across through the particle in a free fall. If you talk about the free fall motion of a particle, right? So suppose I'm going for the skydiving, I mean to say, right, from some aircraft, right? तो skydiving में क्या होता है? So I'm basically saying that I'm taking a book with me. तो मेरे पास एक book भी है, right? So when I take book with me, so after jumping from that this aeroplane, I'm basically this time moving in a free fall. So neglecting the other is the resistance of the air. So before the parachute will open. तो उससे पहले parachute open होने से पहले I am basically coming down under the free fall motion, right? तो अब मैं क्या कर रहा हूँ? I am basically let that book I basically releasing that book from I'm releasing that book. तो इसको मैं छोड़ रहा हूँ book, right? So what I will observe? So I will observe that this book is in front of me and it is moving with a constant acceleration. It's with zero acceleration, I mean to say, right? So that means, so I will observe that the book will move with the zero acceleration under the free fall. So before the parachute will open, right? So that means from my center of frame of reference, from my frame of reference, I will observe that it has this zero acceleration, that book, right? So that means I can write that. If I write now, तो अगर मुझे मेरे पास एक book है यहाँ पे, so what I am observing that from my point of view, so if I choose my this center of frame of reference, so I'm saying that it has that zero acceleration, right? So I will choose that. Suppose the coordinate of that book will be some x mu because I can view the four-dimensional coordinate of that book, right? So that means let us suppose now, let us suppose that this we can say that location of book. So that can be represented by some x of mu, right? Okay. Now, if you talk about now in inertial frame of reference, right? So I can rewrite this as, so that means, or you can write instead of that some lambda here. Okay, let me put the notation same. So it will be some lambda. So it is that it's basically our core vector. Okay, and we can write them. We can write them because it is that book. It is moving with that zero acceleration from my point of view, right? Because I'm choosing my this as my center of mass. I'm choosing myself as a coordinate system and I'm locating that book with respect to myself, right? So what I'm observing that it is moving with a zero acceleration, right? So that means I can write here that d2 that x lambda by d tau 2. Okay. Now, when the free fall motion of this book occurs, because I book मेरे आगे आगे जाएगी, so I will be at the back side of the book, right? So if I choose, if I relate that coordinate of the book, because we are choosing that we have this four vector, this is basically the coordinate displacement of that book, and if I relate it with the coordinate displacement to the surface of the earth, right? So I can rewrite this then. So I can rewrite then. We can write then x of mu. So this is capital X and this is small. So that means this x mu. I'm saying that we are saying that we are writing this coordinate displacement with reference to the ground based reference frame, right? So this is our that ground based that four coordinates, right? So this is how you can relate, right? Or you can rewrite this term. So this term I can rewrite as that is d by d term. right? So this is very clear. So what I did here, I simply take that instead of d2, so I can write this way, right? So this is very clear, right? Now this term basically, now I need to write this partial x lambda by partial t. So I need to write this. So I can rewrite this term as. So if I multiply it by the inverse transformation, this is the transformation matrix also. You can see that. So sorry. So I can convert this into the transformation matrix by multiplying the inverse of this, right? So that means, so जो हमारी equation है, that is basically d by d So that's equal to this, right? So what I will do here, I can write this as, I can write this as some, so we can write that partial x alpha by partial x, right? Okay, so let me write it here. So I can write this as partial mu, but this should be small here, because I am writing this as partial x mu, partial x mu by. So what I did here, so just have a look on this equation. So यहाँ पे मैंने क्या किया, basically transform this. I wrote that because this is what I wrote here, that x of mu can be written as it's a function of that x mu with x mu. X mu. So that means how I can relate that this coordinates of that book with respect to the this reference frame, that is basically on the ground, right? So I'm relating it with respect to the ground now, right? Because it is, the book is coming down under free fall, right? So in that case, you can relate that coordinates x mu with this thing, right? Because this small x corresponds to that 4 vector, which is related to the which is our reference frame of reference, right? Okay. So you can realize. So what I did here, I simply multiply it by or divide by this partial x. So this is what I get, right? No, because so you can use here the product rule again, because as I already told you, so this is simply the example of that. You can say that this curvature of that space, right? So just like in previous topic we have discussed when we discussed the derivative of a tensor. So I can this is one of the example, this affine connection, right? So it connects the two coordinate systems, right? So we can rewrite this term as, so this will be equal to you can write that partial x alpha. So this first term, so because I differentiate this term and this term remains constant, and similarly, we can get this term as, okay. So second term will be equal to, we can write that partial to x alpha by partial x. This is mu partial x mu. Okay, and so we can write here dx mu upon dt. तो यहाँ पे मैंने क्या किया, just have a look on this expression. So if you have a look on this expression, so this is basically, so I basically multiply this. This is partial to x of alpha and this is partial x mu. I basically multiply here. I divide by partial x mu. So this is dx by du by dt, and this is same thing. So ये term हमारी ये है. So this is our this term, right? Right? And differentiation of this, that's partial to this, and I basically add this term. So that is dx mu. So dx mu I basically, so this is same. So I basically modify this, right? So instead of writing the one velocity component, I am writing the two velocity components, one related to the book and another related to the frame of reference, right? And so this is, so if you remember that, this is basically our that acceleration. So this is dx mu, dx d2x mu by d tau 2, right? So this is our acceleration. But so there is some additional term. So I want to get rid of this expression, this term. So I can get rid of this term by multiplying the inverse transformation of this, because this is simply our that some delta, it can be some alpha. So this is simply that inverse this transformation matrix, right? But I cannot write it in terms of delta, because this is capital X and this small x, right? So what I can write here, I can multiply it by the inverse of this transformation matrix, right? Okay. So instead of this, I will multiply here by partial x something divided by partial capital X, right? So I can rewrite this as, so this will be equal to, I can write this as partial x lambda, partial x sum alpha. So let me write it properly. X, right? So this is our first term, and d2 x mu. So this is our first term, right? So just have a look on this expression. तो यहाँ पे मैंने मल्टीप्लाई किया, that is partial x lambda by partial x mu. तो यहाँ पे भी मल्टीप्लाई करना है और यहाँ पे भी मल्टीप्लाई, right? So I can get here. So this first term, second term will be, that is partial x lambda x alpha, and then that's equal to 0, right? So this is very clear. So यहाँ पे मैंने simply multiply किया that partial x lambda by partial x alpha to the first term and to the second term. So why I am doing this thing? Because in order to get rid of this term, because so I should get here that acceleration only, right? Because this part is on at acceleration, and I can get rid of this. So this is simply that. So this and this will cancel. So this will be the delta lambda, because so this can be written as that's partial x lambda partial x mu d2 that's equal to 0, right? So this is our that. So if you remember that, so this term ये जो हमारी term है, that is basically delta lambda, right? तो ये हमारा delta lambda mu है, canonical delta, right? So put by that, because the lambda equal to mu, so this should be equal to 1. So यहाँ पे आएगा, so this will be equal to then, that is d2 x, instead of mu you get lambda here, plus, that's equal to 0. Okay. So I'm getting now the acceleration part, right? So what I did here, I basically made the transformation from so you just check why from starts from here. So we are basically making transformation from some lambda, and finally we are getting that this acceleration plus some new term, because I am making the transformation from some this x mu to x small x mu, because I'm basically making transformation from that for this four coordinate displacement of a book with respect to the earth, right? So this is what we get here. So first term, that's basically our acceleration, and we in addition to that we have the second part, and so ये जो हमारी term है, right? Because this is our velocity component that with this four vector this mu and nu, right? So this is again that velocity, right? Four velocity, right? With different index, and this is our that is called affine connection, right? And instead of that, I can write this as, so this will be equal to that d2 x lambda by dt theta 2. So that means this then mu mu equal to that's equal to dx lambda, that's equal to dx lambda by, or you can write this as, okay, so we'll write it partially because we have this expression. Okay, so let me write it here, partial x lambda. So is it that partial x alpha, and second term is that partial to x alpha by x mu and partial x. So remember that. So wherever that capital, so this capital X and this small x, capital X, small x, right? So this is variation of some old with respect to new coordinates, right? So new coordinates, because old coordinates are that book and new coordinates are Earth. So these are related to this coordinates of the Earth, or core vector, core coordinate displacement, core coordinate this you can say. Okay. And this is our that this is called that is called a F connection. Okay. Now, now we have this term. So with this term, we can rewrite this as this term partial 2 by partial x mu, partial x mu. So we can rewrite this as that's partial 2 by partial x mu, partial x mu. So because it's symmetric, or you can say that these coordinate differentials. So differentials they commute with each other, right? Because I can write this as instead of that equals to partial x nu, then partial x nu, or I can change the direction. So that means, so this condition is valid under the continuity of the derivatives, right? So then you can say that this condition is valid under continuity of derivatives. So this condition is valid under continuity of derivatives. So that means we can say that then this affine, so this T lambda mu, so it includes the three coordinates, right? So first one corresponds to our old and this corresponds to our new coordinates, right? And you can write that then if we have this continuity of derivatives here, if I can write this as partial 2 by partial x nu, partial x nu. If I interchange their positions, then we can say that this should be symmetric in that case, right? So I can write then this, right? So that means it will be symmetric in that case. Okay. So so this uh, this test comes under its transformation under a change of its coordinates, right? So I can give you some physical example, right? If we talk about some Newtonian gravitation, right? So I can relate the affine connection with this that's what's called the gravitational field of the Earth, right? So maybe in our coming lecture, so I will discuss that. So how I can, so if I discuss some physical problem, like if we talk about the Newtonian limit, right? So we can check that this affine connection or this kind of this transformation, it is related to the gravitational field of the Earth. So if we take that this is what is called that, if we take the Newtonian limit, right? So we can maybe we will discuss that in our coming lecture, right? Thank you very much.